Hello, everybody. This is Mr. Mercier here. We are going to start something called the real-life applications of these sine graphs. Okay, I hope everyone did really well on their test. I hope they're having a good time and staying safe and healthy. So there's a ton of real-life examples of when you can use sine and cosine graphs. For your final project in here, we're going to have a performance assessment on these sinusoidal graphs, okay, in both Mr. Mercier and Mr. Crowther's classes, okay? And there's so many different, we're going to have you do some research, and, it's probably going to be the last couple weeks of class where you're not going to have any work except for this performance assessment. So just right off the bat, something, just give an example. So in your house, you got these different things you plug into, okay? These are all 110 volt things that you plug into. Your large appliances like your stoves, your dishwashers, washer, dryer, all that stuff's going to be 220 volts. Okay. Now these circuits in the US are called 60 cycle alternating currents circuits. Okay, so like AC. Okay, so that means that 60 cycle means that your frequency is 60 cycles per second. Now, what you just had a test on, the periods of graphs and that type of thing, the frequency is just the reciprocal of the period. So if I said 60 cycles per second, the period would be 1 over 60. Okay, now it's called 110 volts. Okay, it's actually more technically it's 110 times the square root of 2, but that doesn't sound as good when you're talking about it. So they just say 110, even though it's really 110 times the square root of 2. Okay, now this is how much the volts are going up and down, back and forth. Okay, so in our real life situation here, that 110 times the square root of 2 is actually going to end up being the amplitude of our sine and cosine graph. Now I told you before the period's 1 over 60, so just like you just had a test on, the period is going to equal 2 pi over b. Okay, so if we did that, we would have our b to be 120 pi. Okay, so the equation, now that we have our a and our b, the equation that we would come up with would be right here, where the voltage would be 110 times square root of 2 times the sine of 120 pi times t. Okay, and this is what the graph of those outlets inside your wall look like, the voltage going back and forth through it. All right, and if I look right here, the period is 1 over 60, right? That's when I do my full period, right? It would take 60 of these things to be 1 second. Okay, so that's just one example. I'm going to take you through another example. We're actually going to use the equation to solve some problems. So trig models, okay, they're quite useful in solving many problems that involve periodic behavior. That's what ones that kind of keep on happening over and over and over again. Okay, the example I'm going to show you right now is going to be something of a tide. Okay, and that's what one of your 2 homework problems are going to be on about that. Usually you can use any letter you want here. Typically T, it's time. Most of the time you can use. All right, so let's read through this. So talking about depth of the water at the end of a pier. Okay, now for this example, I'm going to say high tide happens at 4:15, and it's going to be 5.2 meters, and then low tide is going to happen at 10:27 with a depth of 2 meters. So first step, let's find a trig equation that models the depth of the water after midnight. Now, the first thing you should do, we'll worry about being in C in a second, is just draw a rough picture of what's going on. Okay, so it's going to be a wave, and it's going to start at 4:15. Okay, so that's what this is going to look like right here. Now, 4:15. Now, in my graph right here, I want time to be in hours and d to be the height of it. Okay, now 4:15 is not 15 minutes past 0. So since this is hours, I want to switch this to number of hours. So 4:15, if I did 15 divided by 60, I'm going to get 25. So what this is saying is 4.25. So 4:15 a.m. is 4.25 hours after midnight. Okay, so if it was like 4:30, it would be 4.5. Okay, so 1027, if I did 27 divided by 60, I'm going to get 10.45. So the time 10:27 a.m. is 10.45 hours after midnight. All right, now what's going to help me in my sketch is going to help me find what my A and my B are. Now you could use sine, cosine, you could use negative sine, negative cosine. For a lot of these problems, it just kind of makes sense to use cosine so that I know where I can shift it to the right or to the left. So like if I did cosine, it's going to be easy because I'm just going to start my graph right here. Okay, there's no reason you couldn't have done sine and started right here, or negative sine and started right here, or negative cosine and started right here. Okay, all of which would be okay. It just kind of makes sense to start here at cosine. Now my amplitude, so I am up to 5.2 and I go down to 2. So in between those two things, okay, there is 3.2. So that means my amplitude is going to be the line right in the middle of this thing. So it's going to be 1.6 from the middle up, right? So top to bottom is 3.2, so that means the amplitude is 1.6. Now the period is when I'm going to make one full cycle. Okay, so if I think about in between 10:27 and 4:15, that's going to be exactly half of my cycle. What I want to know is what's it going to be from top to the top, right? So basically, since it's going to be top to bottom, if I just kind of multiply that by 2, I'm going to say that it's going to be 12.4 hours from here to here, top to top, or 12.4 from here to here, right? Or middle to middle. All right, now to figure out what the axis of the wave is, okay, what that is, that's just the fancy way of saying where it is in the middle. Okay, that's going to be 3.6. Okay, now what that means is, oops, let me go back. What that means is 3.6 is like my midline, right? That's a line that's right in the middle of 2 and 5.2, right? Because that's going to be right in there. So I know my amplitude is 1.6. So 2 plus 1.6 is 3.6. Okay, and that's going to help me get my equations. Okay, so the distance, so since my amplitude is 1.6, that's going to be right down there. Oops, I don't know how to get that here. All right, and you just kind of plug it in. Let me get that out of here. Okay, so my amplitude is 1.6. Okay, my period. Okay, now I figured out what my period was because I know 2 pi over b equals the period, and if I solve for b, I'm going to get approximately 0.507. Okay, so we're just gonna kind of estimate that now. But if this was like a $2 million boat, you probably wouldn't want to estimate it. You'd probably want to save as many decimals as you could. All right. So to figure out what the depth is at noon, okay, you could type this in the Desmos and kind of figure out where it intersected 12 if you wanted to do that too. But the easiest way is just to plug in the t right into the equation. So I'm going to get the depth at noon to be 2.47. Now for part C said, go back, a large boat needs 3 meters of water, okay, at the end of the pier. So I got to figure out when is it above 3 meters. So I'm going to go to my calculator. Okay, I'm going to do it in a graphing calculator first, and we're going to put this in. Now, the biggest mistake in the calculators is you have to pay attention to all these parentheses. Okay, if you forget this parenthesis right here, you're going to get the entire problem wrong. Okay, so make sure you pay close attention to all these things. Okay, also the next thing is I want to be able to see a good window. If I just type this in, your calculator's set to be in between -10 and 10 for both of them. And if I think about it, I want to go in between like 0 and 24 hours. So I'm going to switch my window to in between -1 and 24. This will give me 1 day. Also, since I'm only in between like 6 and 2-ish, So I just want to get a view of in between 0 and 1. Now to figure out where I'm above 3, okay, you're going to go to the calculate button, and then you're going to go down to the intersect, and then it says like pick 1 or pick 2. Okay, and you can figure out what all of these intersection points are by doing that. Just kind of scroll over it. I'm going to show it on Desmos. A lot of you don't have graphing calculators, so I'm just going to show you how to do it on Desmos also. But the same thing, you're going to put both of those things into Desmos. Okay, I'm going to graph the line y equals 3, and I'm going to graph the line, our equation right there. Now, first two things that you have to really worry about in Desmos is you have to be in radian mode. Same thing with the calculator. Okay, now to make sure we're in radian mode, we go over to the wrench, and by default, it's going to be in radian mode. So the other thing is, just like we did with the calculator last time, we want to get a good view. Okay, so this is what should pop up right when you type it in, right? But we don't really care about negative time, right? We don't care about yesterday, we care about today. So I'm going to switch my x in between -1 and 25. That'll give me from, they'll give me the data that I want. Now for my y values, I'm just going to do the same thing in between 0 and x, and I should get this for my view now. Okay, this is 24 hours, right? So this is a graph of hours past midnight and height on the pier. Okay, next step is to find all these intersection points, and the way you're going to do that is you just take your mouse right in your computer and just tap on these things, and you can get all of these. Now, all these intersection points, okay, let's put them into real life terms. Okay, now this is the hours past midnight. So what I'm going to do is I'm going to take this decimal and I'm just going to times it by 60 minutes. So 0.394 of an hour is 23 minutes. Okay, right here I have so this is 8.106 minutes past midnight. Okay, so this is going to be at 8 a.m. and like a tenth of an hour. So I'm going to do 0.106 times 60 to get 23 minutes. I'm sorry, to get 10 minutes, right? So like to figure out what this time is, right, it's going to be 0.786 times 60. This is going to be 0.4999 times 60. Okay, so in real life, these points are, in real life terms, is like 12:23 a.m. I was at 3 meters. 8:10 I was at 3 meters. And 12:47 I was at 3 meters. And 8:30 p.m. I was at 3 meters. So the question is, when can I safely be in the water past noon? So noon is 12, so I'm looking for this hump right here, right? This is when I'm going to be above that. So I'm going to be in between 12:47 and 8:30 p.m. I can safely do my boat. All right, before I go to the next slide, your verification word is unicorn. So that's going to be the first question on your homework assignment, just to make sure you're actually watching the videos. All right, so your first word problem you're going to have on homework is something called the Bay of Fundy, and it's located in Nova Scotia. Okay, and this is kind of one of the most remarkable tides in the whole world. Okay, so this is just in like a 12-hour segment. It's quite remarkable. So it's just 12.6 hours. I think it has to do with the lunar eclipse, is how long the tides go. Okay, but then I come back and I'll put it here so you can watch it, but slowly it just keeps going down and down over the course of the time. They have really cool tidal pools. There's a lot of neat stuff there. So. All right, guys, so there's 2 word problems. These word problems can be a bit challenging. You just got 2 of them tonight, okay? And all we're going to be working on for the rest of the school year is going to be real life applications of these sinusoids. So give these ones a shot. If you have any questions, reach out to Mr. Crowther or I, or there's an abundance of help videos online. All right, thank you.